Yeah, today's video is again some tricky computations. So let's talk about some tricky computations that I'm going to unreveal. So I've already unrevealed one, and here is another one. Suppose you have 2c plus, sorry, not plus, it's already simplified as this, 2c times 2d. Now we can think of it as 2 times c, 2 times d. Very simple. Now we group the terms 2 times 2 times c times d, which is equals to 4cd. Very simple. It's a way to think about it. But have we thought about it fundamentally? Let's think about fundamentally. This tricky computation is getting real hard. It is it is it is done. Now let's get into the tricky computation. Now when you have, suppose you have 2c times 2d. Now it means c plus c, man, this, I hate this phone. C, man, c plus c times d plus d. This whole sum of c multiplied with d, that's what this thing means. Now here comes the main problem. Before this, let's understand the main concept of this tricky computation. So the main concept of this tricky computation has, if you have c times d plus d. Now we know the distributive property. What does it state? C times d plus d, because here it means that d plus d is added c times. Now if we grouped the term, we would get cd and cd. I will tell you why if we grouped the term. Now here it means d plus d is getting added c times, and here the c is a rational number which is not a ratio, and it is a whole number. That means it's not also not a decimal number, it's not an infinite number, it's not an infinity. Oh yeah, that's what it says. Infinite number and whatever number. It's an integer with a positive value. Negative value, it can be negative, it can be positive, but not an infinite. It is negative or positive, but it can be infinite. C is such a value. Then C would be distributed over C and D. Let's think of it now. You can write it as D plus D plus D dot C times. C times, because we don't really know C times, but we can think of it as, we cannot think it. That's what it's actually getting. If c was a number, if it was 2, then d plus d is getting 2 times added. So that's how this thing is working. Okay, so now if we group the terms, suppose let's take the c's, instead of c let's take 2. Now we can surely see 2d times d plus d. You can, of course, you can say that I'm so dumb, you can write it as 2 times 2d, because 2d literally means d plus d, and you just multiply the numbers. But still, let's try to understand it fundamentally, or truly what it actually means. It means c plus c multiplied with d plus d. But when you write 2 times 2 times c times d, that means d is multiplied getting with c, that means d is getting added with c times, and 2 times 2 means 2 is getting added 2 times, or means 4. Now it means, so c, d is getting c times, so it means c times d and 4 times c times d, that means c times d is added 4 times, which is 4cd. Very simple. Like 4 times CD can't be multiplied into further. But when you have 2D, it can be, it not can be, it is D plus D. So let's multiply D plus D or add D plus D 2 times. Now we can see D plus D, if we add D plus D, you can get 4D. So it makes sense now, it's 4D, right, as there is 1, 2, 3, 4D. Now what if it is C? Now let's get back to C. So dot 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 C times dot dot dot, as I wrote, C times. Now if it was C, now of course the first D, look, the distributive property stays there. Like if A plus, like if it was like A times B plus C, that means B was added A times, C was added A times, so get AB AC. In, like with the same logic here, the first D or the previous D was added C times, and the second D was also added C times. We get CD plus CD. Now we cannot add the values of D uh, because of the C, because CD plus CD is just CD, because C doesn't representing a number. If it was plus 1D plus 2D, then we could represent it. Also in that case, we can replace this D here to make it easier. We can replace this D here with A prime and B prime. Let's replace A prime and B prime. Now A prime plus B prime. Now if C times A plus B prime, we can see that A plus B prime was added C times. Now we know, let's write this here, A prime equals to B prime equals to D. So in this case we can have C A prime plus C B prime, because these both numbers were added C A prime. Now substitute A prime and B prime, we get CD plus CD. Now instead of adding the D's, we instead just simplify it to 2CD, because that's what it literally means. Now I think we understood what it actually meant and how it actually happened. As like, even though if you grouped the terms, you cannot group the CD term until you write it as, like, if you have to take the whole CD, you cannot just take the D because of the C. Very common sense. Now let's go into the much more complex. Let's take this sum of C plus C is E. So we get E times D plus D. Now we may use the distributive property as we explained before. The first D was added A times, the second D was added E times. So ED plus ED. So we get ED plus ED. Now substitute E, C plus C times D plus C, like this same thing, C plus C times D. So now we switch places to like simplify further, because we cannot simplify in this stage, because the C plus C times D literally means D is added C plus C times, which is, you are locked in this state. But even though you know the distributive property, if you use it blindly, like if you multiply the D with C, if you multiply the C with D, it will work, but it's just technically, not technically, it's just eventually turning this into D times C plus C. Now you may say, right, that D times C plus C gives us DC plus DC. But listen, when you get DC plus DC and CD plus CD, even though they are same, even though their structures are different, but the main problem is we don't really need it. A great example is 2 times 3 and 3 times 2. 2 times 3 means add 2 3 times, and 3 times 2 means add 3 2 times. Even though they give us the same result, they give us different structure. Adding 2 3 times completely different number, different times are added. Adding 3 2 times also different number, different times are added. So that's how it actually works. So by just switching places, you can simplify further. You get d times c plus c plus d times c plus c. It's kind of like here. Now we just apply the distributive property, or we just can write it as dc plus dc plus, wait, let me ease it a little bit, equals to dc plus dc dc plus dc plus dc plus dc. So now we can repeat it as, I can rearrange it as cd plus cd plus cd plus cd, because when you have d times c and c times d, it doesn't matter because we cannot pluck out, we cannot literally do anything from this thing. We have nothing to do here, you just add them first, and whatever you do, it just adds. Like when you have 3 times 2 plus 2 times 3, you cannot plug anything or plug in or anything within the structure or do anything within the structure. You cannot work with the 3 times 2 structure. It will work as it wants. If you work with the structure, if you plug out a 2, it will completely change the meaning. Like if there's 2 times 3, it means 2 being added 3 times. But if you take just like minus 2, give a minus 2, or just pluck out a 2 and you just add 2 times, then it would be a different value. So when you have 3 times 2, you have to add 3 times 2. And if you give minus 2, then it works because 3 times 2 is 6, 6 minus 2 is 4. It's like you can add anything with the structure, but can you do anything with the structure when you say 3 times 2? If you do, it will change the value of 3 by 2. But to, like, is there any possible things that you can do? Like, is there any other way to arrange 2 without adding it 3 times? Because it's just saying, like, to add 3 times 2, it's just saying to add you 3 times 2, so there is nothing to do. It's a very common sense, like that's what it's just saying, you add 2 times. If you just don't care, then don't care, you'll get a different value. I just told you something and you did something, there's nothing to say. So let's rearrange it a little bit because of L. Like if we rearrange to c times d, now it will just, as order just matters the structure not the value, so the value is just same, just c plus d looks nice, so that's why we just use it. So now we can write as cd plus cd plus cd plus cd. Now in total we have 4 cd because we cannot add the d's but the c's, so you can write it as 4 c d. Done. It's a really complicated computation if you think so, like d is added c plus c times, then why all the d shouldn't be added? But you have to think that, look here, the d is getting added c plus c times. Like if you think so, it gets really complicated.